Next, let's move into serous membranes. Always, we have connective tissue, and we have epithelial tissue. So, superficial epithelial, deep connective, what kind of cells are making up these tissues. For epithelium, we're going to have simple squamous. Instead of just saying what, we'll say why. And then for our connective tissue, we have loose areolar. How do we remember this? Instead of having mucus now, we're going to have serous fluid coming from these serous membranes. Serous fluid. So when I think of fluid, I connect that with loose and fluidity. So that's how I make the connection. And let's check out how this serous fluid is made, and then that'll answer the whys of why it is simple squamous. What color do we want? Let's just go blue. So our simple squamous layer, and then that underlying connective tissue. If you guys remember connective tissue, like, yeah, we say connective tissue proper versus bone and blood and stuff, but when you're looking at a picture, for example, slide, give me a sec, let me find it. If you look at slide 6 in his picture explaining the basement membrane, which talks about epithelial and connective tissue, if you look at this picture, you don't have one type of connective tissue down there. He identified a blood vessel in this picture, and but right now we're talking about loose and areolar. So just remember that connective tissue is a kind of broad term because you might find multiple different types of connective tissue in that connective tissue layer. But the main one we're talking about is this areolar or loose. Regardless, in this connective tissue, we've got these capillaries. These capillaries are leaky by design. So if I have blood's flowing through my capillaries, okay? This blood contains this fluid called plasma, and that plasma can leak out. So it's going to leak out, and it's going to put a bunch of fluid in here. This epithelial layer is also going to secrete something. It's going to secrete something called hyaluronic acid. So let's draw some of that in here. And when I mix this fluid, so I get fluid from cap, that looks like fluid. That's fluid from a capillary plus this hyaluronic acid. This is where I get my serous fluid. So serous fluid is this thick, viscous, slippery fluid. Well, what makes it thick and viscous and slippery? I shouldn't use that word, thick. I don't know how thick it is. It's viscous, which means it does have some resistance, and yeah, and it's slippery for sure. But why is it slippery? Hyaluronic acid is rich in carbohydrates or sugars. So this sugar is adding this slippery feeling to this fluid that's coming from our capillaries. So, once again, for a recap, where do we get this serous fluid? Because the whole point of a serous membrane is to produce serous fluid to help lubricate our organs. So, how do we get it? We know we need a fluid part and we need a slippery, viscous part. Fluid part comes from the underlying connective tissue. These capillaries are leaky by design, and they allow fluid from the blood to leave the capillaries in the space between these two different types of cells. And then this phenomenon of this fluid leaking is called capillary, wait for it, leakage. So fluid leaking from the capillary is called capillary leakage. And that epithelial tissue is again going to secrete the hyaluronic acid, which is rich in the carbohydrates. That's making it slippery and viscous. So some of this, we talked about the areolar tissue, so there's some fibers in this areolar tissue that's helping connect all this stuff together, which just a note. Now, where are we finding these serous membranes? So they're going to line closed ventral cavities. So if you've looked at a rat dissection, here's his head looking up, there's his arms, and then he has this open cavity, and here's his legs. So this thing that separates, this is called the diaphragm, and that's going to separate your thoracic from your abdominal pelvic cavities. All right. So we have a bunch of different organs, right? I have my stomach in there, my pancreas in there, my small intestine in there, my liver over here, my gallbladder right there, my appendix right there, my spleen over here. So the whole point of this is when I move around, like when I'm doing circles or jumping around, jumping up and down, these organs are going to move across each other. So if they weren't wet and slippery and viscous, if they couldn't slide, then they'd cause friction and maybe tear each other apart. So what serous fluid's function is? So if this is the serous fluid function, then this is the serous membrane function as well. And what its serous fluid or membrane functions. What this is, it lubricates organs to prevent friction when movement occurs. So that is the function of the serous fluid or the serous membrane. Let's look at a little bit more about its structure. So we have two layers to this membrane. We have a visceral and we have a parietal. So the parietal, I always think of this as the parent layer because when you're a kid, your parent watches over you, watches over your shoulder, whatever, to make sure you're doing your homework or your chores or whatever. So this top layer, this outer layer, this is the parietal layer. And this lines whatever cavity we're talking about. So whether it's the thoracic or the abdominal pelvic, this is going to line the cavity. The visceral layer, this visceral means guts. So even though technically your lungs and your heart aren't considered guts and those have serous membranes, visceral relates to guts, and all your abdominal pelvic stuff, that's like, those are your visceral organs. So the visceral layer means of the organ or lines the organ. Cool. So two layers. And I need to ask him because I've never really had to think about this or question this. This is a membrane, so this has the epithelial connective and this has the epithelial connective. I'm 99.999% sure of those. And then you have this space, and depending on what serosa we're talking about, we're going to give that space a different name. So again, the parietal layer is lining the cavity, either the thoracic or the abdominal pelvic, and then the visceral layer is going to line any of these organs in the thoracic or abdominal pelvic cavities. So, excuse me, different types of serosa. So serosa is just plural for serous membrane. And we have three different types. We have the pleura, we've got the pericardium, and we have the peritoneum. So I know we have a lot of P words here, along with parietal, so let's break them all down. Here's my person, or rat, whatever you want to say. So here's my diaphragm. Above there I have those lungs, and below I have a bunch of stuff. We'll just do stomach, and we'll just keep the stomach for now. And we need the heart as well. The heart really sits right here, but I'll be able to draw it off to the side because it's easier to see. So the pleura means, the adjective for lungs is plural. So the pleura is the serosa of the lungs. So it has two layers. It's got the parietal layer, which lines the thoracic cavity. And it's got the visceral layer, which surrounds the lungs. In between, there's fluid called pleural fluid. Now, I know the heart sits in the thoracic cavity, but it gets its own parietal layer. Let's draw that one. There's my heart. Surrounding it is this fibrous sac. So when you cut it open, or when you look at the heart in class, it's like this yellowish, grayish sac, and you have to use a scalpel to get through it. Now, this is all the parietal pericardium. The outer lining of the heart, this guy here, that outer layer of the organ itself is your visceral layer, or your visceral pericardium. In between these, we have a space, and it gets filled with a bunch of fluid, which is serous fluid, but in this case, we call it pericardial fluid. So let's break up this word pericardium. Cardium, if you've heard of cardiac, okay, cardiac bypass, this relates to the heart. Peri means surrounding. Okay. Talked about pleura, that's our heart, that's our lung, serosa. Talked about the pericardium, that's our heart, serosa. And now let's look at all these different, let's look at the serosa of the abdominal pelvic cavity. So we're going to have a parietal layer of this peritoneum. And then, again, we have multiple organs. I'm not going to name any, let's just draw a few. Each of these is going to have a visceral peritoneum. So that's going to have a covering, that's going to have a covering, that's going to have a covering. So if I just draw those 3, 1, 2, 3, and then I draw the abdominal pelvic wall, here's my parietal layer. Here are my visceral layers. And then there's this fluid in between, and that's called peritoneal fluid. So those are serosa. Let me see if I wanted to mention anything else before we move on. Alright, if you had to ask yourself, which serosa are in which cavity? Well, which of the serosa are in the thoracic cavity? That would be your pleura and your pericardium. Which are in the abdominal pelvic cavity? That's your peritoneum. And that word is peritoneum. That's the serosa itself. This is the adjective. Alright, synovial membrane. We're not going to talk about these much because when we go into bones and joints, we do a whole section on joints and we really get into it more there. But we do just want to know a few things. So one thing we want to know, it's connective on connective tissue. It's going to secrete something called synovial fluid. This isn't serous fluid, this is synovial fluid. What word are you looking for? You're looking for the word joint. Synovial membranes occur in joints. When you talk about a joint on the test and it talks about fluid, it's not talking about a serous. It's talking about synovial fluid. And this is just going to lubricate joints. Make sure the ends of your bones aren't grinding together and stuff. Movement's going to occur at joints, so the ends of your bones, those articulating surfaces of the bones, that's where bones are coming in contact with each other, so it's just going to add some lubrication. Alright, we'll end there, and then we'll finish this section up with tissue repair and germ layers and stuff.